All right, I wanted to make a quick video showing you how to find the derivatives uh, along a function, so at any point using a graphing calculator, TI-84 graphing calculator. So basically, you can find the slopes of the tangent lines at any point on a function. So let's put in start with. Let's go to um, the graph editor, which is under y equals the equation editor, which is under y equals. So hit y equals, and then what we're going to do is we're going to actually graph sine of x. So if I hit sine of x like such, I could go to graph, and it looks something like that. Now, if it doesn't look like that, it could be a couple of reasons. One, it could be that your zoom is on zoom standard instead of zoom trig. So that's what zoom standard looks like. So if you go to zoom and you go down to zoom trig and hit enter, then that might be one of the reasons why it doesn't look like that. Another reason might be that your mode is not in radians. So make sure you're in radians. So go to mode and make sure you're in radians because radians is what we want to work in. So here's degrees, here's radians. Make sure you're in radians. So we go to graph, it looks something like this. As we know, we can trace. And so if you hit trace and go left, you can see all the different y values that correspond to all the different x values. But the cool thing is you can plug in values in terms of pi. So I can say negative, and the pi is right here. It is the blue, the second blue under the little caret there. So if I say second caret there, that's pi. So that's negative pi. If I hit enter, it'll tell me the sine value at negative pi. So negative pi is right here. This is negative pi over 2. This is negative pi. This is negative 3 halves pi. This is negative 2 pi. And so you can see it gives you the decimal equivalent of pi right there. It gives you the y value, which is 0. If I put in negative pi over 2, so I put in pi divided by 2, and hit enter, it gives me the y value there. It is 1.57. Well, that's the decimal equivalent. I'm sorry, that's the decimal equivalent of negative pi over 2, and then here's the y value, negative 1. All right, so we can also find the slope of the tangent line at that spot, which is pretty cool. So not only can we find the y value, we can find the slope of the tangent line. And the way we do that is we go, see how that says calc there? We can do second trace, and that takes us to calc. So second trace, and here's some different calculations that you can do on your graph, which is really cool. And we'll talk about some of these as we go along. Value is just the same as trace. But one of these options is the derivative. So I can go down to 6 and hit enter, and it'll take me the derivative of that spot. Well, I'm sorry, it'll tell me I hit the derivative function, and now it'll say, where do you want to find the derivative? And so now I can put in any derivative I want to. So I can say negative pi over 2. And not surprisingly, not surprising. I think not surprising is what I want to say. Not surprising, the derivative is 0 because the slope of the tangent line would be 0 at that spot. So at negative pi over 2, the slope of the tangent line would be 0. So it gives me 0 just like I would expect. Now I can do it at negative pi. So I can do this again. I can go to second calc, and I can go down to derivative. And this time I'm going to put in negative pi. So negative and then pi, and it's going to give me the slope of the tangent line. So the x value is negative pi, y value is 0, but the slope of the tangent line at that spot is negative 1. And that's not surprising either. So you can imagine a line right here that is tangent to the graph, and that looks like a slope of negative 1. It's going downhill, so that makes a lot of sense. So you can find the slope of the tangent line or the derivative at a specific point for any x value on this function. Furthermore, you can find the slope of the tangent line or the derivative for any point on any function as long as you put it into the function editor right here.